A very good morning to everyone. Today we are going to discuss about the topic pipes connected in parallel. In fluid mechanics, when we talk about pipes connected in parallel, a pipes is said to be in parallel when they are so connected that the flow from one pipe branches or divides into two or more separate pipes, and then it can reunite at similar points. So we can say, for example, we have a pipe, and at section 1 we have discharge Q and diameter D, and at section 1 this main pipe got divided into two pipes, say 2 and 3. These are the two pipes it got divided into, and the length of these two pipes before they reuniting is L1 and diameter D1, L2 and diameter D2. And at section 2 they got reunited into again a single pipe. So we have a discharge Q which is coming into this pipe, and discharge Q again which is going out at the section 2. So when the discharge means, we all know it is rate of flow or flow per unit time. So when the discharge of any liquid, when it enters into the section, it have two ways. Either it can go through second pipe or it can go through third pipe. So the discharge occurring in second pipe, say it is Q1. If the discharge occurring in say third pipe is Q2, then the total discharge Q will be a summation of Q1 and Q2. And when these fluid coming out to the section 2, again the discharge will become Q. So in parallel pipes, we have the discharge of the entire section will be the summation of discharge of each branch pipes. Okay, so this is the first point you should remember when we talk about pipes in parallel. And about the head loss, when we have head loss, we know head loss due to friction is the major head loss occur in pipes. So when we talk about frictional head loss, HF, this HF will be same in all these pipes. Say if HF is a head loss due to friction in the main pipe, and HF1 is a head loss due to friction in the pipe 2, and HF2 is a head loss due to friction in the pipe 3, then we can say HF is equal to HF1 is equal to HF2. So these are the 2 points which you should remember when we talk about pipes in parallel. So I think it's clear. Discharge will be the summation of each. Total discharge of the pipe will be the summation of all the discharge of branch pipes, and head loss at each branch pipe will be the same. Okay. Now let us see some problems regarding this parallel pipe. Okay. So first question. A main pipe divides into two parallel pipes which again form one pipe as shown in figure. The length and the diameter of first parallel pipe is 2000 meter and 1 meter respectively, and while the length and diameter of second parallel pipe is 2000 meter and 0.8 meter. So find the rate of flow in each parallel pipes if total flow in the main pipe is 3 meter cube per second and the coefficient of friction for each parallel pipe is same and is equal to 0.05. So we have the figure like this. Here it is said that my main pipe divides into two parallel pipes which again form one pipe as shown in figure. So this is a figure, and the length and diameter for the first parallel pipe L1 and D1 is given. L1 is given as 2000 meter, D1 is given as 1 meter, while the length and diameter of second parallel pipe, that is L2 and D2. L2 is given as again 2000 meters, and D2 is given as 0.8 meter. So it is asked to find out the rate of flow in each parallel pipe. So let us term the discharge or rate of flow of first branch pipe as Q1 and second branch pipe as Q2. So we have to find out Q1 and Q2. If the total flow in the main pipe is Q, that is total flow in the main pipe is capital Q is equal to 3 meter cube per second. So it is given as Q is equal to 3 meter cube per second, and the coefficient of friction for each parallel pipe is same, that is F1 is equal to F2 is equal to F is equal to 0.005. So these are the given values regarding the question. So here we have to find out Q1 and Q2. So while we talk about two parallel pipes, as I discussed just above, we know head loss due to friction will be same in all pipes. So we can write HF1 will be equal to HF2. And coefficient of friction we can calculate by using equation HF is equal to 4FLV square by 2GD. Here we have F1, first pipe, so we will name it as 4F into L1 V1 square divided by 2G D1 is equal to 4F L2 V2 square divided by 2G D2. So we know this relation. From this we can calculate V1, or we have to calculate V1 and V2, then we can easily calculate the Q1 and Q2. So from this equation we know we can just cancel out similar terms in right hand side and left hand side. I'm just cancelling out similar terms. So we got L1 V1 square by D1 is equal to L2 V2 square by D2. Okay, so L1 V1 V1 square by D1 is equal to L2 V2 square by D2. So L1 is 2000 and V1 square we don't know, so we keep it as V1 square itself, and D1 is 1 meter is equal to L2 is 2000 and V2 square we don't know, so we are keeping it as V2 square itself, and it is D2. D2 is 0.8. Okay, D2 is 0.8. Fine. So we have V1 and V2. We are going to make a relationship between V1 and V2. So we are relating V1 and V2 by V1 square is equal to 2000 got cancelled. V1 square is equal to V2 square divided by 0.8. So we got a relation V1 square is equal to V2 square by 0.8. So I am keeping it aside. Okay. Now we have V1 square is equal to V2 square by 0.8. Now we know Q1 can be calculated by using Q is equal to area into velocity, or I can write A1 into V1, where A1 can be calculated by pi by 4 into D1 square into V1. So D1 is known, so I can write pi by 4 into D1 is 1, so pi by 4 into 1 into V1 square. In from equation 1 I can write V1 square is equal to V2 square by 0.8. Therefore I can write V1 is equal to V2 divided by root of 0.8. Okay, so I am writing, instead of V1 I am writing V2 divided by root 0.8. So I have Q1 in terms of V2, and I also make I'm also going to find out Q2 discharge at second pipe Q2 from A2 into V2. We have pi by 4 into D2 square into V2, and I'm just writing D2 square is 0.8 square, so pi by 4 into 0.8 square into V2. So we have two equations, and from parallel pipe equation we know discharge from the main pipe is equal to total discharge or summation of all discharge in branch pipes, or I can write Q is equal to Q1 plus Q2, and Q value of Q is given as 3 meter cube per second. So I can write 3 meter cube per second is equal to Q1 plus Q2. So I'm writing down the same equations just we found out above as pi by 4 into V2 divided by root 0.8 plus Q2 is pi by 4 into 0.8 square is 0.64 into V2. Okay, by doing the math we will get, this is V2, okay, we get 3 is equal to 0.8785 V2 plus 0.5026 V2, or I can write V2 is equal to 3 divided by 1.3811, which is equal to 2.17 meter per second. So its velocity V2 is found out. It is equal to 2.17 meter per second. Okay. So by knowing V2, we know we can calculate V1 as V1 is equal to V2 divided by 0.8. So V2 is 2.17 divided by root 0.8, root of 0.8. So the equation value of V1 will become 2.427 meter per second. So the value of V1 is 2.17 and value of V2 is 2.427 meter per second. So by knowing V1 and V2, we can calculate Q1 and Q2 as Q1 is equal to A1 into V1, which is equal to pi by 4 into D1 square is 1 square into 2.427, and Q2 is A2 into V2, which is equal to pi by 4 into 0.8 square into 2.17. So the values are Q1 is 1.906 meter cube per second and Q2 is 1.094 meter cube per second. So this is the answer for the question. I hope you understand.